like the total grade being like a 15.
Okay, everybody, you ready?
Like if you were to bring it to 100 scores, like a 15.
Wow.
Okay, let's take a look at the sheet that I just gave you. All right, everybody. So today we are basically going to go backwards from what we were doing. So before I would give you the equation, ask you, hey, what's the vertex? What's this? What's that? Today, you are going to be given some information and we're going to try and come up with what the equation is. All right, so it will be helpful if we remember our forms. So vertex form was y equals a times x minus h squared plus k, where h comma k is the vertex. Yep, so that's a general form though. Y equals a times x minus h squared plus k. Right, which is why, so see how the vertex is at positive h comma k? So if you saw like x minus 4 in there, it would really be at 4 comma, because you're doing the opposite. All right, so there's vertex form. And then the other one that will be helpful will be intercept form. And that, if you recall, is y equals a times x minus p times x minus q. And what are p and q? I know you need to mind them, but yes, those are your x-intercepts or your roots of your quadratic, okay? So x and, not x, p and q. P and q are the roots or x-intercepts. Okay, so it's kind of up to you what form you're going to use, but it's also based off of what information is given to you. So if I look at the very first one, they're telling me where the vertex is. So I will probably use vertex form. I don't know where, I have one x-intercept, but I don't have the other one. So instead of going through all the work to figure out where the other one is, why wouldn't I just jump to vertex form? And then, yes, I can use this x-intercept as extra information, which I do need. If you think about it, if I just said, hey, give me the equation of a parabola with a vertex at 1, 3, there's an infinite number of parabolas that have its vertex at 1, 3, right? Couldn't you draw like 10,000? And then you just keep going. So if I want just one of those, I have to give you some other bit of information. One other point on the line, for example. Okay, so I have lots of information, number one. Let's go ahead and try it. When you're given the vertex, right? Remember that's H and that's K. So when I go to plug it into the formula, I'm going to plug each of those in, one for H, one for K. I know this is an x-intercept, but again, I don't know where the other one is. If I were given both of them, it would be a different story. So I'm actually kind of gonna ignore that it's even an x-intercept. I'm just gonna use it as some other point on my parabola. And for any other random point, it's just an x and a y. So basically what I'm gonna do is I'm gonna plug those 4 pieces into the vertex form, and there's only gonna be one thing left that I don't know. What's that one thing that's left in that formula that I don't know? A. But what I can do is I can solve for A with all of these other numbers in. So let's go ahead and do that. So we'll use vertex form. And take a moment and just plug in all 4 of the numbers that we have. So y in this case is 0. A is the thing I don't know, but I have x is -4 minus h, which is a -2. What happens when you have minus a negative? Because plus the positive, right? Squared, and then plus k will be a -5 on the end. So once you have everything plugged in, we should be able to solve for A. So take a moment. So that'll be a -2 squared is 4. I don't like how it's written with the A after it, so I'm just gonna write it as 4A minus 5 instead. Right? It's the same thing, but and now all I have to do is solve for A. So let's add that 5 over and divide by 4. I'm going to give you some step-by-steps over on the left because I realize that there really aren't any here. So first, you're going to decide if you're using Vertex or Intercept. Let's say decide what form you're going to use, because you can use standard form, and in fact, we will tomorrow. Decide what form you're using, what form to use. Let's go with that. 2, plug in everything except A. Solve for A. And then your last step, once you finally know what A is, you have to write the equation. So you're going to write the equation using the vertex, if that's what you're given, or the intercepts, if that's what you have. And the value of A. So that's the step that we're on now. I need to write my equation, but I need to go ahead and what am I doing? Oh, I gotta just put all my pieces together. So y equals, I now know that A is 5/4 and X, so I'm using the vertex. So minus -2 turns into a +2, and then K is at a -5. So there's my final answer. There's my quadratic that will have that vertex of -2, -5. And it should also go through this point. I'm not really using that as an X-intercept, but it just so happens that it is. So I could check it really quickly. If I plug in -4 for X, I should get out 0 for Y. And it looks like I do. Yep. So just get a 0 there. Does that make sense? Everybody's all right so far? All right, now the second one is a different situation. And I kind of want to, I think I want to jump back to number 2. Let's jump to the third one for a second, and then I'll come back to the second one. So I'm going to give myself a little bit more room. So I'm going to talk about the third one over here. Okay, so this one, I'm given my 2 zeros. They're at -2 and +4. And then they've given me, this is like that extra bit of information that I need in order to figure out what A is. Because think about it. If I said, hey, draw me a parabola that has zeros at -2 and at +4, couldn't you draw me a million parabolas that cross through those 2 points? There's so many you could draw, right? You could draw one that's down like a frown. You could draw one that's up like a cup. You could draw a really wide one. There's so many that you could do, right? So if I want exactly one of them, I need this extra piece of information. There's only going to be one parabola in the whole universe that has zeros at these 2 numbers and passes through this point. So I always need that extra bit. So I either need the vertex or the intercepts plus some other point. You with me? Okay, let's try it. So this time, since I am given both of my zeros, I'm going to use intercept form. What are these going to go in for in our formula? The -2 and the 4. They're not H and K because that's the vertex. P and Q, exactly. So it doesn't matter which one's which. Call one a P, one a Q. And then what am I going to put this in for? Cedric?
Like the X and Y.
Yes. Yep. That's just some other point that I have in X and Y. So I'm going to go to my intercept form. And I'm going to plug in all the pieces that I have. Watch your signs here though, right? Okay, so Y is 1. A is what I don't know. X, I do know, it's -1. Minus, P is a -2, so minus a negative turns into a plus. Be careful. The next one, X again, so another -1 minus whatever Q is. Oh, this time it's a 4. So now you have all of the information in there. You just need to go ahead and solve for it. Okay, did you get what I got? A -1/5 for A. We agree? Are you guys with me? I feel like I'm alone on this algebra-free planet. No? All right, well, let's see what happens now. Now that I have A, I know what it is, a -1/5. I'm gonna go back to my my just general formula. And this time, since I use the vertex, I use the intercept form, I'm gonna go ahead and plug in those intercepts. So when I have my final equation, the only variables that should be in there are X and Y. Everything else should be filled in. So the P's and Q's should be filled in, A should be filled in. I'm just gonna have X and Y's left in there, okay? So my final answer would look like Y equals, A is a -1/5. Leave the X, but minus P. So minus -2 turns into a +2. And then the other one would be in X minus 4. And there it is. How do we feel about that? Not so bad? Not so bad, hopefully. And if you were, taking a quiz or a test or SATs or something, and you needed your final answer to be in standard form, well, you can just take your answer and turn it into standard form if you had to. There's not an easy way to jump directly to standard form. There is a way. It's a way more difficult. And we'll be looking at that tomorrow, you lucky ducks. But anyway, so the reason why I skipped number 2 is because number 2 is kind of weird and you have some options here. So here's what I know. If I go back up to number 2. I really need more space on these pages, but anyway. So I know where the zeros are. So I do have P and Q. The problem is I don't exactly have a third point. They didn't just come right out and say, like in the other one, hey, here's another point at -1, 1. They said your maximum value is 4. That means the highest this graph will ever get is a Y value of 4. Now, at what X value does it happen? It's not that hard to determine that, but you would have to do a little bit more work to figure out where it's happening. Can anybody tell me the X value, where this maximum value is occurring? Go ahead, Sandra. Yes. So wouldn't that be a -1? Right? Because doesn't my vertex has to happen halfway in between my zeros? right? So they've given me the y coordinate. They just didn't give me the x. So it's not that hard to find. I just would have to go through that one extra step. Does everybody follow? Okay, so what I really can figure out is that I do actually have a vertex at, what do we say, -1?
-1, 4.
-1, 4. So now it's kind of up to you which form you use, because you have both pieces of information. You have the vertex, so you could use vertex form and just choose one of these as your additional point. Or you can go ahead, you have both intercepts, you could use those and then just plug in the vertex as your extra point. So that's up to you. We should all end up with the same equation. They may not look the same, but if you converted whatever you get to standard form, we should all have the same thing. So take a moment, go ahead and get your equation. I would use intercept form personally. I would think that's easier, but that's just. Okay, we got an answer? Yeah, so here's what I would have done. Again, if you use vertex form, yours is probably going to look a little bit different. I would have used this as my x and y. So I'd have 4 equals, I don't know what a is yet, but x is -1 minus -3. So it turns into a plus. And then x again, a -1 minus 1. Go ahead and solve for a. Let's see what we get. That's 2. That's a -2. So I get 4 equals -4a. So a is -1. Cool. So then your final answer, if I put all the pieces together, y equals a is -1, and then I'd have x plus 3, x minus 1. So there's mine in intercept form. If you had this in vertex form, I suppose yours would have looked like y equals, a would be the same, right? So you should have a negative x plus 1 squared plus 4. Did everybody do it in vertex form? I believe you should get this. You did? This is what I'm saying it would be. Y equals negative, then x plus 1 squared plus 4. Yeah. Okay, cool. So, and if we change both of these into standard form, they would match exactly. So, if it doesn't specify what form you have to have it in, you can leave it in any of them. All right, so we feel okay so far? Now, if you look at the fourth one down. Hi.
Thank you.
Thank you. Grace, I have yours. Want me to put it on the big screen?
Yes.
No.
Yes.
No.
It's lovely. It really is. Oh,
Yeah, put it on the big screen.
no, I wouldn't.
That's my board.
Let's see.
Mine are bad.
Really?
Yeah.
Wait,
Yeah,
here, let me see.
That's
Wait,
Well, I was trying to.
I feel like Derek
No, I was
just-
trying.
I feel like there could be the one.
There, let me see. Wait, there.
Okay, everybody. So now, before we do these last two, are you with me? I want to show you something before we jump into that one. Let's say I had a quadratic with zeros. Let's just say A was 1 and the zeros, you don't have to write this down, but I just want to show you something. Zeros are, how about -4 and +6? Okay, that means that this thing would have come from x plus 4, x minus 6. Right? If I were to turn this back into standard form, I'd get x squared minus 6x plus 4x minus 24. Or x squared minus 2x minus 24. All right, you follow me so far? So this was just a simple example because I want to show you something. There's a pattern here, which I'm not sure that you're really aware of or not. Maybe you are, I don't know. This number at the end, C, -24. What does that have to do with my original zeros? Do you see a relationship between the original zeros that I had, -4 and 6, and then what ends up being C, -24? It's just the Jake? Yes. If you take the product of whatever the zeros are, you're going to end up with this number down here. Now, -2. Huh. So this is the product of the zeros. -2. What does that have to do with these two? Grace, you with me? Cedric? Close. If I add -4 and 6, I get a +2, but here I have a -2. So it's almost as if I am subtracting whatever the sum is. So here's a way. This is the, actually, let me do it this way. If I have -2, so the 2 is the sum of them. Sum of zeros. You'll see why I'm doing this in just a minute. Okay, so a simplified version is going to look like this. AX squared plus B is going to be the sum of my zeros times, oh, and I already messed up. That should be a minus sign. Sorry. Minus the sum of the zeros plus whatever the product of the zeros is. Now, this is going to save me a whole heap of time when I go to do something like the fourth one down on this sheet. If you take a look at the fourth one down, in fact, let me go ahead and copy this over on this sheet because this is kind of important. Sum of zeros times x plus the product of the zeros. Okay, so here's what I want to show you on this fourth one down here. Don't write this because you're not going to want to do it. But if I were going to try and do this the same way I had done, like the third one or even the second one, it gets to be kind of a nightmare. Because if this is, P is going to be 2 plus √3, right? And then Q is going to be 2 minus √3. So when you go to plug these pieces in, don't write this, but watch how bad it gets. I have X and Y. So I'd have 4 equals A times X minus all of that. And then X minus Q, all of that, 2 minus √3. And you'd have to multiply all that together in order to solve for A. Doesn't that seem like a nightmare? Because it is. You can do it, absolutely, but it takes forever and it's super annoying. So when your zeros are these complex numbers that have these rational and irrational parts, or like in the last one, we have a real and an imaginary part, we are not going to bother with that. We are going to just use this. I'm going to take the sum of my zeros and the product of my zeros. That's going to save me so much time. Okay, so take a minute before we move on, and I just want you to take these two zeros, find their sum and their product. I'm not sure that there is one.
Because I just, like, I knew like I couldn't find one, so I was like, okay, I'll do a negative. But it's just
Are you doing the last one or the
yeah,
fourth
I'm
one?
doing the last one. Actually.
Don't do that one just yet.
Okay.
You know what, before we get too far, I'm so sorry, I forgot to set a parentheses. You want parentheses around all of this. You want A times all of that.
What part do you want this one?
I don't want any decimals. Hold on. Okay, let's do it together.
But when you took out the zero.
Don't do this. Okay, you can do that. So again, I would avoid that at all costs. You can do it and you can get the right answer that way, but it's so much easier to just use this. So I'll say use this instead. Okay, so let's find the sum of our two numbers. So if I have 2 plus root 3 plus 2 minus root 3, isn't the sum of those just going to be 4? Right? If I add these all together, one of them is 2 plus root 3, the other is 2 minus root 3. Add that together, I get 4, because those root 3's cancel. Sure. So far, are we okay? Is everybody with me? Now, let's go ahead and do the product. The product will be a little bit hairier, but it's not nearly as bad as doing this, I promise. So I'm going to have them multiply 2 plus root 3 and 2 minus root 3. But we kind of get lucky here. First is 4 outside. You're going to have a minus 2 root 3, and on the inside, you get a plus 2 root 3. Oh, that's not so bad. So those cancel. And what's a positive root 3 times a negative root 3? Close. Negative 3. Right? Because my sign's going to be negative. Yep. And now 4 minus 3 is just 1. So now I have the sum of my zeros and the product of my zeros. So now all I have to do is pop that in over here and I can solve for A. So check this out. Let me do it first before I plug in the X and Y. So I'll have Y equals A times X squared minus the sum of my zeros would be a minus 4X. Plus the product would be a plus 1. See how much easier that was? And now all I have to do is go ahead and plug in that X and Y and I can solve for A. So Y is 4. I don't know what A is, but 0 in this case is a 1. So 2/3. Thank you. Silly goose. What?
What did you do with that extra much?
That's what we did with this thing. So I took this general formula. Sum of my zeros is gonna go there, and the product of my zeros will go there. And we already had the sum of the product, so then you just pop them in. So now I'm evaluating, that's 1 squared minus 4 plus 1. So the -2a. So I get -2 as my a. So now I'm ready finally for the last step. I'm just going to have to pop in what A is. You can actually go right back to this step right here. Just replace A with what I now know it is. So my final answer, y equals -2 times x squared minus 4x plus 1. And I'm done. A nice thing to do is to just quickly check your answer, right? You know it's supposed to go through the point 1 comma 4. So if you plug in 1 for x, you should definitely get out a 4. And I think we do. 1 minus 4 plus 1 gets me -2 times -2 is a positive 1. Yep. Goes so fast. How are we feeling? Okay-ish? All right, we got one more to do that has an imaginary number in there. I'm going to do this on the back so I have some room. So the zeros are at 3 plus minus 4i. 3 plus 4i, I'm going to separate them. And 3 minus 4i. And pass it through 3, 1. Three comma 1. Right, is there a negative? No, okay. All right, so again, I don't want to do, I have my zeros, but I don't want to plug them in directly because it would be a multiplying nightmare. So to save myself all that hassle, we're going to find the sum and the product of our zeros. Sum of zeros. So go ahead, take those two and add them together. 3 plus 4i plus 3 minus 4i. What comes out? 6. Prince, what's up? Can you wait till Grace gets back? Thanks. Okay, so I have 6 for the sum of the zeros. Let's go ahead and find the product of the zeros. So I'm going to FOIL together 3 plus 4i and 3 minus 4i, but you already know the pattern, right? First are going to be 9. The insides and the outsides are going to cancel each other out here, right? We're getting lucky because our zeros are complex conjugates of each other. Remember that? So when you multiply them, right, the outside and the inside are just going to cancel out. So you could just skip over this step, but I'll write it out just so we have it. So I'd have a minus 12i and a plus 12i, which are going to cancel each other. But what is positive 4i times negative 4i? Go ahead, DJ. Yeah, so at first it's negative 16i squared, right? But what's I squared? Negative 1. So you might write it as negative 16i squared at first. But anytime you have an I squared, you need to remember that that's really just negative 1. So what you have is 9 minus 16 times negative 1. So I end up with 9 plus 16. Whoops. And that's how I end up with the product of my zeros as 25. Jake.
So isn't I just by itself -1, so then I squared would be +1?
I by itself is square root of -1. Yeah, so, right, I all by itself is square root of -1. So if you square it, that takes care of the square root part. Okay, so now we have our sum and our product. So now we're almost there. We just have to figure out what A is. So remember what we're gonna do. We're gonna write it as y equals A. And then I'm gonna have x squared minus the sum. So my sum was 6x. And my product is plus 25. So that's where I'm at so far. Is everybody okay with where I'm coming up with this from? We're using sort of that shortcut. So we're always going to subtract the sum, and then we'll just add on whatever the product is. All right, and now I have that other point, 3, 1. So I just need to plug that in for x and y, and then I can solve for A. So 1 is y, A, x is 3. So now you're just evaluating. Oh, what's that? 16? Double check me. Are you guys getting what I'm getting? You did? 116? So now that I have that, I can literally just go right back here and I'm just gonna replace A now with 116. So that gets me my final answer. Helpful to check yourself real quick. You know, when you plug in 3, it should come out with a positive 1. That's such a nice, easy way to just sort of see like you didn't, because there's a lot of pieces here. It's easy to drop the ball somewhere. So if we quickly just throw in a 3, 9 minus 18 is a -9 plus 25 is 16. 116 times 16 is in fact 1, which is what we were expecting to get. So I feel good. Thoughts? Nothing? Do you understand or are you, I don't know. I feel like you guys are hard to read today.
Yeah, really bad.
Well, good thing in 15 minutes class is over.
Oh, can't we just go on our
Really quick walk,
What?
really
Wow.
quick. Grace hasn't,
Yeah, I haven't been on
Great.
it.
yeah, we've gone on so many
I need
walks
to go
without
on the
Grace.
new one.
I think she deserves one.
I don't think that's-
Can you
I-